So let me define a few other things. Typically we're interested in V out, right? We have some circuit, we input our signal generator, and we say, hey, what do we get out, right? That's our circuit, and we define sort of that characteristic of the circuit as the gain. It's just V out over V in, and that's the gain. And so you might say, well, I'm going to put in some input function, I multiply by the gain, and that tells me what am I going to get out. And so a lot of times we'll plot the gain versus the angular frequency, right? Because the gain varies over some wide frequency. We typically do a log plot, and it turns out that the half power point, when you have half the power out that you put in, is proportional to V squared. Okay, that's just something you can look in an introductory textbook. And so the power out over power in is equal to the gain squared. So when the power out is half, power in, or power out is half of power in, then you have P out over P in is a half. V naught squared over, or the V out squared divided by V in squared is equal to a half. That means the gain squared is equal to a half, or that the gain is equal to 1 over the square root of 2. Okay, why is that? Well, it turns out the half power point is an important point, and I'll show you why in a second. So Bode plots are essentially the gain plotted versus frequency, only now we're going to do a log-log plot because we want to see what's the change, and the change can be large over some time. Typically we're looking at power. So we plot 20 dB log the gain versus log omega. That's what we mean by a Bode plot. And so when we cut the power in half, which we just showed, we said the power out over power in is a half, or the gain, the magnitude of the gain is equal to 1 over square root of 2. If we plug those values in, what that means is 20 dB log times the gain, if that's 1 over the square root of 2, is equal to minus 3 dBs. So a decrease to half power is a change in 3 decibels in the gain. Okay, and so that special point is called the 3 dB point, and that point is defined to be when power out is equal to half the input power. And so that becomes an important point later when we talk about filters as a characteristic of a circuit. What's the 3 dB point? And so that'll help us kind of just get a handle on what's going on.